Okay, so now what we have is we have the sine of 2x equals the square root of 3 over 2. So now we're dealing with a little bit different function. That's not the sine of x that we know how to graph that. Now it's got a period of 2 pi. This change in this coefficient of x here is going to actually, kind of change the whole picture of the graph. And the nice thing is that we want to just find the solutions on this half open interval, 0 to 2 pi. So we're back to our restricted domain. So we're just going to be looking at, one or a finite number of periods. That means we can count them. Okay, so remember, what is the period of this function? Because that's going to give me a little bit of insight of what's going on. So remember, the period equals 2 pi over b, where b is the coefficient in front of the x. So in this case, b will be 2, so the period will equal 2 pi over 2, which just equals pi. Okay, well, let's just sketch this so we can get a look at it first so we get an idea. So if this is my normal 2 pi, that's my normal period, then right in the middle would be pi. And this would be pi over 2. This would be 3 pi over 2. And if this is 1 and this is negative 1, this is y and this is x. Okay, then normally our graph would start here, would go up to 1 here, back down to negative 1 and back up here. Okay, but because the period is just pi, I have to divide that, so I've got to put some other markers in here, so I can divide this into 4 equal spots. Now remember, the sine of 0 is 0, so I know I'm going to start at 0. I'm going to go up 1, back down 1, down again 1, and back up, and I'm going to get my sine curve. And if you get mixed up between the sine and the cosine, just go to your unit circle and they say the sine of what is 0, or the sine of 0 is what? If it's 0 here, if the cosine of 0 is 1, so you start there for the cosine, and then they just alternate. So that's one period, okay? But my domain is from 0 to 2 pi. All right, so I actually have to look at 2 periods of this. It might be nice to do the second period in another color just so you could see. So again, we go up 1, back to down 1, and getting back. So it's going to go like this. And this is the second period, but it's in that domain where I'm looking for the roots. So we have those 2 periods. All right? This is a primary period, but this is over the domain, so I actually have 2 cycles of the sine function between 0 and 2 pi. Now, if we have any particular value, we can see how many solutions we'll have. So this graphing method is nice to reaffirm this. When is the sine of 2x, or when is this? And this is actually, this graph is actually y equals the sine of 2x because of the period changes. So this, we're looking to see when would have this vertical position. Now remember, the square root of 3, we talked about this in class. A good approximation for the square root of 3 is about 1.7. And then if you divide that by 2, that's going to be 0.85. So we can say that we're looking for the value here when it's actually about 0.85, which is about there. So if I drew a little line here, you'd see we have a solution there, a solution there, a solution there, and a solution there. So over this, from this 0 to 2 pi domain we're talking about, restricted domain, we actually have 1, 2, 3, 4 places where this sine curve, the sine of 2x, is actually equal to 0.85 or the square root of 3 over 2. This is our approximation. So we'll have 4 solutions. That's what makes it, a little more complicated problem. So I hope you kind of appreciate that. Okay, so let's go back and let's just take our basic. Now let's just think of this as x. If this was just x, okay, the sine of what or something, we call this something. The sine of something is the square root of 3 over 2. What's the something going to be? Well, that 2x would equal pi over 3, because the sine of pi over 3 is the square root of 3 over 2. Okay? Now also that something could be, since it's positive, it could be also in the second quadrant, because the sign is possible in the first and second quadrant. So it could also be 2x could equal 2 pi over 3. Okay. So we got those two possibilities, pi over 3 or 2 pi over 3 for 2x. In other words, if I take the sine of pi over 3, I get this. If I take the sine of 2 pi over 3, I get this. But we're looking for x. We're not looking for 2x. So if we want to find out what x is, we usually divide by 2, but it's usually a little bit easier because of fractions. It's a little harder to divide pi over 3 by 2 rather than multiply by 1/2. So a little easier way to do that is multiply both sides by 1/2. And what's going to happen is you're going to end up with x equals pi over 6. Okay? And then over here, the same thing. If I multiply both sides by 1/2, I'll end up with x equals, and that's going to be pi over 3. Okay, so those would be these would be the solutions, and I think you can see how this makes sense. This would be pi over 6 over here, and this would be the pi over 3 over here. But we also have these two values. Now it's really easy to see this. This is in the same position of the function. It's just shifted over to pi. I'm shifted over pi. Excuse me, because that's the period. So I would add pi to this because of the period to get the next value of it, or the next cyclical value. Yeah, the next cyclical value. Okay, or the next time it's this height in the function would be one period over, or and if you think about this distance to here would be just pi. So I would have to add pi for the next value, and then I wouldn't, if I added pi again, I would be outside my restricted domain. So one value is going to be x will equal pi over 6, and the next one would be x would also equal pi over 6 plus pi, because that's going to shift it over. And that's the same thing as pi over 6 plus 6 pi over 6, right? Because that's the same thing as pi, and I made that into 6 so I could add that, and that equals 7 pi over 6. So these are the two values built off of this, pi over 6 and then 7 pi over 6. Now let's take a look at the pi over 3. X equals pi over 3. All right, but we want to get the next value, so that's going to be another, actually, period over. So I'm going to add another, see, for we go all the way from there to there is another pi. So I've got pi over 3, and I've got x also equals pi over 3 plus pi. Okay? But that's the same thing as pi over 3 plus, and I want a denominator 3, so 3 pi over 3, and that equals 4 pi over 3. Okay? Unless we want to put them all in the same denominator, that's fine. Okay? So now we basically have four answers: pi over 6, pi over 3, 7 pi over 6, and 4 pi over 3. So those are your four answers. And we usually put them, when you see them in a solution set, they usually write them in ascending order. So the smallest one would be pi over 6. The next one would be pi over 3. And the next one, see this first one, the next one pi over 3, and then this one, which would be actually the 7 pi over 6. And the last one would be the 4 pi over 3 over here. So that would be your solution set. Okay? Alright, so I did do a little more explanation. I'll try to do the other problems a little bit shorter, but I kind of gave you a little bit insight of this. This is what we did in class also, so if you happen to miss that, at least you can see what's going on here, and hopefully you get an appreciation for how these things work, okay? So that's number 25. So that's a doozy, isn't it? Hope that helps.